Hello friends, welcome back to another lesson in the course to learn basics of coding. Last time we talked about variables and how variables are stored in the memory. In this lesson we are going to talk about pointers and arrays. These are two important concepts in C++ as well as in general coding. Pointers are extensively used in C++ as well as C. They're also used in other languages, either directly or indirectly. In addition, arrays are used in every language. So let's get started with pointers. As the name suggests, pointers point to something. So pointers are really variables that can reference or point to other variables. Pointer enable a lot of scenarios that otherwise cannot be done without pointers. Pointers allow you to do dynamic memory allocation. They will enable scenarios or uh, help you to enable data structures which otherwise would not have been possible. Let's get started with some code. I'm going to copy paste some code here that I have already written. So I'm declaring a variable char ch equal to a, and then I'm declaring a pointer here. This is the syntax to declare a pointer. I'm saying char star pch1, and then I am making this pointer reference the variable or point to the variable, or I can say point to the memory location of the variable ch. And I'm doing this by saying ampersand ch. That's the notation we have to use. Finally, I'm creating another pointer variable, and just to mention, this star indicates that this is a pointer variable and not a normal variable, normal char variable. And in this second variable, I am setting this second variable to the first pointer that I created here. So basically, this pointer will start pointing to ch because pch1 is also pointing to ch. So the reference of pch1 is actually going into pch2, and that is because pch1 is already pointing to the variable ch. Note that I am not saying ampersand pch1, otherwise it would be like storing a reference of pch1, or having this pointer point to pch1 instead of ch. So just note this difference. When I want to point my pointer to a specific variable, I will say ampersand ch. But if I want my pointer to point to the same location where another pointer is pointing, I will not use ampersand. So this will actually make pch2 point to the same variable where pch1 is pointing. Finally, I'm printing the values here. So if you see ch, this is the standard way we saw earlier in the lesson for variables. But here we are actually doing star pch1. So to point, what this is doing is this is making me point to ch and print the value of the variable ch. So basically this star pch1, this is the notation. This says that go to the memory location where this pointer is pointing and print the value, and that is the value a. Same thing for variable pch2. Let's just go ahead and build this, and I'm going to go ahead and run this. Let me bring this window on the current screen, and we can see that ch printed a. In addition to that, the star pch1 and star pch2 printed a, because they both are pointing to the variable ch. Let's do another thing. We are going to change the value, and let's print the values again. So in this case, I just changed the value to b, Note that I'm setting it on the pointer. I could have set ch equal to b. Since this is a pointer variable, I'm saying star pch2 equal to b. It would be same as saying ch equal to b, because this star says go to that memory location and update the value. And finally, I am printing the variables again. Let's go ahead and build this, and we'll run this again. So we should see the values in a moment. Yep, and we can see by changing this value for the pointer star pch2, we actually see the change has reflected for all ch, star pch1 and star pch2. This is because they are pointing to the same memory location of ch. Let's see how this actually looks. So I declared a variable ch and it has a value a, and it is declared, let's say it's created, this variable is created at a memory location with address 100. So when I declared the pointer pch1 and pointed it to the variable ch, it actually, like when I said char star pch1 equal to ampersand ch, it started pointing to the memory location 100. Note it might have its own address, but the key is that it is pointing to this memory location. This itself is a variable, that's why it might have its own address on the stack. And finally, I created another variable and made it point to the same memory location. So if I change the value here, I change it to b, and I reference it either through either of these pointers or through the variable ch, I will get the same value as we saw in our code. Let's go back to the code, and what I'm going to do is I'm going to just do one more thing, and this I want to demonstrate that the pointer themselves are variables and they have their own address. So if I run this, we should be able to see the address of the pointer variable pch1. You see this 0x79fe08, that's a hexadecimal number. This might probably not work if I print for ampersand ch for a reason that we will see when we come to arrays. Now the pointer, I can also do something like this. I can declare pointer for any data types. So if I want to declare a pointer pointing to a integer variable, I'll just say int star pi and reference it to the integer variable in the same manner as I did it for the character variable. And finally, star pi will print the value of that pointer, or the location where the pointer is pointing to, that is the variable I. Let's build it one more time, run it again. Yep, we can see the value 10. What I'm going to show you next is I'm going to talk about using the new and delete operators with pointers before we go to arrays. So I'm just creating a struct here, and I'm setting a variable. I'm just creating a variable as part of that structure and setting its value. And what I'm going to do is I'm going to use the new keyword to declare that to initialize the object of that structure, or the variable of that structure. So if you see, pretty much similar to what we did here, test1 star obj1. So basically declared a pointer here of type test1, but now I'm doing new test1. So what this does is this will dynamically allocate memory for this pointer, and the pointer will point to this memory location. And notice that when I'm accessing obj, the variable s of this object or of this variable, I have to use this special notation, hyphen and the closing angular bracket. So whenever you're accessing members of a structure or classes, which we will see in future videos, you have to access those members in this way, either to set the value or to print it. And finally, I am deleting this object. So since we are allocating memory dynamically, we need to make sure that we delete this object or this variable, otherwise we will have a memory leak. So let's go ahead and let's run this. Yes, so we can see that I set the value to C, and then when I print it, the value or the character C is printed on the screen. We cannot access this object after deleting, after calling the delete operator or the delete keyword, because this object will not exist in memory anymore. So let's talk about arrays. Now I'm going to copy paste some more code, and we are going to declare an array. So now an array is basically a collection of we can call it as a collection of variables of the same types, but it's really one variable. It's a collection of elements of the same type, and the way it is denoted is using the square brackets, opening and closing. We say that we are declaring an array, and then we are declaring more than one values, if you see. So unlike I said char ch equal to a, here I'm saying declaring an array, and I'm declaring about 1, 2, 3, 4, 5 values. Now this is a special character called as null character, and I'll explain it. We'll see why we need this when we come to using pointers with arrays. But as of now, just understand that this is an array of 5 elements. The way we index this element is way we access these elements is using the index. So charr square brackets of 0 will give us t, charr of 1 will return e, charr of 2 will return s, and so on. Let us go ahead and let's print these values. So we can say that test has been printed on the screen because we are actually printing all the characters except the last one. Now what I'm going to do is I'm going to declare a pointer, and I'm going to print a few things. Let me go ahead and close this. Let's rebuild this. Let's run this. And we should see the values printed in a moment. And if you see, this test was basically where we printed the array manually, but then let's first see what's happening here. I declared an array and I pointed it to I declared again a pointer, and I pointed it to our array charr, and then I declared another pointer, and here I did something interesting. I actually pointed it to the first element of this of the array. So charr of 0 returns me the first element, and then I'm saying that I'm actually saying ampersand charr. So both these statements are basically equivalent. Both these statements are the same. So a pointer actually points to the first element of the array, and now I'm accessing this pointer in the same way I would have indexed an array. But note that I'm not using star here, and there's a reason for this. And let's go back to let's go back to the output. If you see charr pcharr of 0 actually printed t. Same thing with the pcharr of 2, pcharr2 of 0, it also printed t. If I just say pcharr of 1, which is, so the pointer is actually pointing to the first element, it actually printed the whole string. So test, that's what it, that is what it printed, right? So now what we'll do is, let's see what happens when I print star of pcharr1. Let's just do this. Run it one more time. See, so here we can clearly see this is the char pointer, and it's pointing to the first element of the array. So star pcharr actually prints only the first element, and if I just refer it to as pcharr, it's actually going to refer to the whole array, and it's going to print the whole array. So understand the difference here. This is going to be, I mean, quite important difference when you're coding. And if you understand these few syntaxes, pointers should be pretty easy for you. Now let's actually see how this all looks. So now why printing printing just the pointer actually printed the whole array? The reason for that is, when we declare an array are basically same like similar elements of the same data type, but they are also in the location they are stored in like a continuous blocks. So when I declare this variable test \0, and I still need to explain why we need this, and I'll come to this in a moment. But if you see, these variables are declared in sequential address, assuming that if the first value is 100, first address is 100, or the address of the first index is 100, the next one will be stored in 101, 102, 103, 104. And the difference is like 1, because a character variable takes only 1 byte. So this takes 1 byte, so the next one is in 101, this takes 1 byte, next index is at 102, and this takes 1 byte, so next index is at 103, and so on. If I were to declare an integer array, they still would be in continuous sequential blocks, but the address would vary. So since integer takes 4 bytes of memory space, assuming first address is 100, the address of the second index would be 104, third one would be 108, and so on. And when I point a pointer, the pointer is going to point to this address 100. And when I print just the pointer, it actually prints for a character array, it prints everything until it finds this null character. So it knows this is the end of the string, and this is where uh, this null character comes into place. In case of integer, this is not applicable. We don't have anything like this null character. What we actually need to do is we need to make sure that we don't access indexes outside the bound of this array, or outside the upper index of this array. Otherwise, the program might run into errors. The program will actually run into errors. Let's go back to the code and just do a quick recall because this is such an important topic. So we declared a variable and we saw how we can declare pointers and reference or point to the variables. We can have any type of pointers, any data type, we can have a pointer. So we did here like an integer variable and integer pointer. Similarly, we did it for a struct. When we are using pointers for custom or composite data types, we need to use the new operator to allocate memory, and we should make sure that we delete that variable after use. In addition, we looked at arrays. We looked at a string or a character array, and then we also looked at how pointers and arrays work, how a pointer actually points to the first element of the array. So these two statements are pretty much equivalent, and then we also saw how we can access the elements of the array. We will definitely get into more advanced topics for pointers and arrays in the subsequent lessons. But I will strongly recommend that you spend some time understanding or making sure that you have a grasp of these syntaxes, because these are things that are going to be used frequently. And if you have a good grasp and good understanding of these concepts, pointers become much simpler to use. That's all for today's lesson. In the next lesson, we will look at a few other concepts, a few other basic blocks of programming. Bye for now. Thank you.